Now we're gonna talk more about the actual structures of the brain. And the brain can be divided into two hemispheres, the right hemisphere and the left hemisphere. The left side of the brain, so the left hemisphere, is responsible for the right side of the body, while the right hemisphere is responsible for the left side of the body. And left brain is primarily responsible, so by saying left brain, I mean left hemisphere, is responsible for language, so speaking, writing, and understanding, and it is also more responsible than the right hemisphere for math abilities, judging time, rhythm, and coordinating the order of complex movement. The right hemisphere is especially good at perceptual skills, such as recognizing patterns, faces, and putting together a puzzle or drawing a picture. It also helps us to express our emotions and detect the emotions that other people are feeling. There isn't usually just one hemisphere that is responsible completely for one activity, but it is rather the work of both hemispheres doing their own parts and sharing the information with the other side. However, there are still hemispheres that are more responsible or for certain activities, as I mentioned a few seconds ago. But what happens when we cut the pathway between the two hemispheres? So there is this pathway connecting the two hemispheres. If that pathway is to be cut, you would have a case of split brain. Split brain is a term to describe the results when the corpus callosum, which is connecting the two hemispheres of the brain, is severed for a certain reason. It is the association of symptoms produced by disruption of or interference with the connection between the hemispheres of the brain. The surgical operation to produce this condition, the split brain condition, results from transection of the corpus callosum and is usually a last resort to treat refractory epilepsy. Please stop the lecture right now and check out the YouTube clip showing a patient with or an individual with a split brain. As you probably saw, it was pretty amazing how information that you present to the right hemisphere, the individual is not capable of verbalizing, but is able to draw. And information presented to the left hemisphere, the individual is able to say, but not draw. And that is talking about the elements that the left hemisphere is more responsible for the language. So when you show a picture of something to the left hemisphere, the person is able to say it. Another syndrome that can happen as a result of brain injury in this case is spatial neglect. And spatial neglect is when the patient pays no attention to one side of visual space. As you can see, on the left of the drawing, that's what the model was. And on the right, you can see what the patient drew. In this case, which hemisphere was damaged? Right hemisphere or left hemisphere? The right hemisphere. And once again, remember, the right hemisphere is responsible for the left side of the body. In this case, we see that the spatial neglect is on the left side, meaning that the damage has occurred to the right hemisphere. Each of the hemispheres can be divided into several smaller lobes. Frontal lobes associated with higher mental abilities and play a role in your sense of self. They're also responsible for control of movement and direct the body's muscles. There is an agreement among researchers that the frontal lobe keeps developing approximately until the age of 25. Thus, teenagers and young adults are perhaps not thinking clearly through the consequences of their behaviors until they reach the age of 25. Keep that in mind when making, big life decisions, that it might seem like a wise decision, but it might be that your frontal lobe, if you're below the age of 25, has yet to fully develop, and maybe wait with, big life decisions until your frontal lobe is fully developed. The frontal lobe also includes the motor area that directs the body's muscles, and changes in behavior, environment, neural processing, thinking, and emotions can lead to altered motor maps. So for example, as you can see here, there's a lot of the area of the motor cortex associated with our face. And it's because there are more nuanced elements in our face that we can exhibit and show. Same for fingers and hands, but not as much for our knees or so much for the toes. If somebody is an athlete, for example, the motor area associated with the hands, if it's handball or basketball, for example, might be even more developed than somebody who is not an athlete or not engaging in that sort of sports activity. The frontal lobes also include association areas that combine and process information. A person with damage to the association areas in the left hemisphere may suffer aphasia. Aphasia is the impaired ability to use language. The first type of aphasia is Broca's aphasia, and it's the speech disturbance resulting from brain damage that involves issues with grammar and pronunciation. Please check out the 2 videos posted on Canvas of a girl who had a stroke, and which resulted in damage to the Broca's aphasia area. And there is her talking immediately after the stroke, and there is her talking 5 years after the stroke. You don't need to listen and watch the whole video, just the first minute or so of each of them to kind of show you the differences between immediately after the stroke and 5 years after. Two additional lobes are the parietal lobe, which is the area of the cortex that includes the sites in which body sensations register, and the temporal lobes, areas of the cortex that include the sites where hearing registers in the brain. As I said, there are 2 types of aphasia. The second type is Wernicke's aphasia, and it's speech disturbance resulting from brain damage that involves issues with language comprehension. This area is located in the left temporal association area. If this area is damaged, the result is a fluent aphasia. Though the person can hear speech, he or she has difficulty understanding the meaning of words. And tempo, so music, rhythm, serves as a motivator for response. Individuals with Wernicke aphasia try to move on the beat, and then they speed up the rhythm that results in them responding faster. Please check out the two videos showing one example of a girl who suffers from Wernicke aphasia. And the second one is ABC News segment showing a previous senator, I believe, after she was shot in the head in the area of Wernicke aphasia, and how her therapists use music in order to speed up and help her respond. And the last type of lobe is the occipital lobes, and it's the portion of the cerebral cortex in which vision registers in the brain.